Alright, so physics 10 15 10 10. This is units and measurements, the very first topic. The first thing that I want to you guys to be introduced to are base units. Okay, the base units. This is the very first thing that you did when you reached grade 10. The first topic in physics you did was units, and you looked at these base units. Okay, so we are going to first look at base quantities and their SI units. Let me put IES. All right. The base quantities. The first one, we have got seven of them. You looked at them in high school. The very first topic that you did. The first one, I'm going to bring out the first ones and then you guys are going to be telling you. You have got mass as a base unit, or you call it as a primary quantity, like base quantity or a primary quantity. And then you have got temperature, you have got time. Okay, apart from mass, temperature, time, you have got also a mole, or let me not say more because that is going to be the unit. So we say the amount of substance. I'm going to say amount. What other base quantity do you know? There's supposed to be seven of them. Anyone? Any base quantity you know? Yes, now luminous intensity, very good. Anyone else with another one? Length, very good. Anyone else? Yes.
It's a question. It's amount of what? Amount of substance, more or something.
Yes,
What's
amount
the
of
question?
substance.
Alright.
Yes, Titus. Now, yes, please.
Oh.
Electric current, very good. Are these seven? One, two, three, four, five, six, seven. All right, we have all the seven. Now you need to know their SI units. SI units. Now mass, the symbol that we are going to use for mass is just a capital M, temperature capital T, time capital T, amount of substance. I don't know what we are going to use as a symbol. Luminous intensity, I don't know. Length, we are going to use L. Electric current, current we use A. Now they are units. Mass, the SI unit for mass is what now? Kg, very good. And then uh, the SI unit for temperature, Martha Chanda, the SI unit for temperature, a Kelvin. No, 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 forget about the degrees, it's not SI unit. Ammon, what's the SI unit for time? Yes, seconds, very good. Amount of substance. Messi Mutute, what's the SI unit for amount of substance? Amount of substance? Yes, Titus. Very good. A more. Okay, let's go to Mutinta. What's the SI unit for luminous intensity? Mutinta. Okay, Amon. What's the SI unit for luminous intensity? Nathan. Nathan is a candela. Now, not write. I'll not write the. I'll write the symbol C, capital C and small d. All right. We can switch off our mics. Okay. We know length is measured in meters and electric current is the SI unit is an ampere. Now I wrote the SI unit for the unit. I mean for the unit, yes. So the SI unit is ampere or amps. but current itself, the symbol is I. Now these are base quantities and they are SI units. Please know them. It's as simple as this. Physics section A. They'll bring one of these. Multiple choice. Now we also have derived quantities. Derived quantities are quantities which come from base units. Base units. Meaning that you are going to get it from one of these. So for example, you have got velocity. Okay, you have got velocity. How do you find velocity? Velocity is given as the distance over time. Of course, it's changing distance over changing time. Okay, so that's velocity. Now we can write this dimensionally in dimensions. So we're going to say velocity is equal to what is distance? What base quantity is distance? The base quantity is length, right? And remember length we use the L. Okay, we're going to say L like that. I'm going to put it in this bracket. And then over time, well, of course time, the base quantity is just time, and we use capital T, right? And then we're going to put it in brackets like this, meaning that the dimensions for velocity, I'm going to take the T on top. We are going to have L, and then we are going to have T, but when T goes on top it carries a negative one. So these are the dimensions for velocity. We know that length is given in meters and time in seconds. So this is going to be meter and second to the power negative one. This is the unit for velocity. So dimension analysis is very important in determining the unit of a quantity. Okay, if you want to determine the unit of something, you get to use dimension analysis using the dimensions. And the dimension that you are going to be working with is the dimension of time, mass, and the dimension of length. Please take note of these three: length, mass, capital M, and time, capital T. Now you are using dimensions, you don't care their unit. You don't care about the unit, all you care about are the dimensions. Let's look at acceleration. We look at the dimensions for acceleration. So acceleration is given as what? Is given as velocity divided by time. Now at the same time, we know that velocity itself is distance divided by time. But remember, we already have time down, so it will be time squared. So here the dimensions for acceleration, we have got distance. The dimension for distance is length. And then down we have got time squared. If I take the time on top, we are going to have length and then time to the power negative 2 since it has gone up. That's why the unit for acceleration is meter second to the power negative 2. That's the dimensions, and so that is the unit for acceleration. So dimension analysis is applicable here. Now let's look at a force. A force. We know that force is given by mass multiplied by acceleration. Newton's second law. At times we're going to say force, another type of force which is way to be mass times gravity. Gravity is simply acceleration, so it's the same thing. Okay, we know that the dimension for mass is an m, right? M. We have already determined the dimension for acceleration, and we saw that was what? L, and then t to the power negative 2. So these are the dimensions for force. We know that force, the unit for force is what? A newton. That's the unit for a force. This means that if newton, 1 newton, which is the unit for a force, this comes in multiple choice. 1 newton is the same as, what is the dimension? What is the unit for mass? It is a kg. What's the unit for length? It is a meter. What's the unit for time? It is a second to the power negative 2. This means that 1 Newton is the same as 1 kg meter second to the power negative 2. Or you can say 1 Newton is the same as 1 kg meter per second squared. So if I put per, then the power become positive. Please take note, 1 Newton is the same as a kg meter per second squared. For multiple choices sake, take note of that. Let me talk of pressure. We know that pressure is given by force divided by area. We also know that force is given by what? Mass multiplied by acceleration and then divided by area. What are the dimensions for mass? Mass is capital M. And then acceleration, remember acceleration A is velocity over time. Remember also velocity is distance over time. So acceleration is distance over time squared. So the dimensions for acceleration is what? Distance. Now what's the dimension for distance is L. And then we have got time squared down, so put time down, and it's supposed to be squared. Remember, down we also have area. How do you find area? Area is given by length times length, so I'm multiplying length two times. Okay, so that is the length squared. Now here, remember what is okay, we have got one length on top, it will cancel with one length down. Yes, Martha.
So I'm lost why you put the L on acceleration.
The L.
The L on top there.
Like it
Okay.
comes from here. Acceleration is given by distance over time squared, and distance is length. That's why I've put the L there. Is it okay?
I was wondering, yes, but I was wondering why the T squared went.
Okay, the T squared is here in the denominator. And so this is going to give us one L will cancel with one L. So remember, one L will remain with one L down, right? So meaning that we are going to have mass, okay? And then I'm going to take this L which has remained here on top. When it goes on top, it will carry a negative 1. And then I'm going to take the T which is down on top. When it goes on top, it carries a negative 2. Now remember, pressure is measured in a Pascal. So the unit for pressure is Pascal. And we know that since we are saying pressure is force over area, force is given in what? Newtons. And area is given in meter squared. Okay, so 1 Pascal is the same as 1 Newton per meter squared. And this is going to be equal to, what's the unit for mass, which is M? It is a kg SI unit. SI unit for length, it is a meter. SI unit for time, it is a second. So 1 Pascal is the same as 1 kg meter second to the power negative 2. Actually, this is also supposed to be meter to the power negative 1. Remember, it's this one. Okay, so 1 Pascal is the same as 1 kg per meter to the power negative 1 second to the power negative 1. Not per meter, but 1 kg meter to the power negative 1 second to the power negative 1. Remember, these two which have got negative powers were in the denominator, meaning that I can also write this as kg per, and if I put per, the negative goes, so it will be kg per meter second to the power negative 2. Please take note for multiple choices sake. So if they give you this unit, just know that's a unit for what? Pressure. So they might bring this. Alright, do we have any question? Any question?
Yeah.
Yes, please be free to ask.
On 1 Pascal.
Okay, 1 Pascal. So remember, we've said the Pascal is the force over area, right? We know the unit for force is what? A Newton. And then area is given in what? Meter squared. That is why 1 Pascal is the same as the 1 Newton per meter squared. Like we know the unit for pressure. Pressure is measured in pascals. Pascals, pascals. Now, from the dimensions that we've determined here, since the dimensions are able also to tell us the unit of something, meaning that 1 Pascal, which is the unit for pressure, is going to be equal to the unit given by these dimensions. We've got mass we know that is given in kg. Length is given in meters, and then time is given in seconds. That's why 1 Pascal ends up being equal to a kg per meter second to the power negative 2. Actually, if I put per here, these are you are able to find this option, it will be wrong. If I put per, the powers are supposed to be positive, not negative. Okay? Because remember, if I put per, it's the same as putting over. When something is in the denominator, you've seen that the powers were positive. So it's supposed to be positive. Pa, is it Patricia, Patra? Is it okay now?
Yes, fine, it's okay.
Alright. So we forget about this a bit. Now, as you get to talk about these units that you've seen, the SI units, apart from the SI units that you are able to see, we also have prefixes in measurements. Okay, mass is not always measured in kgs. It is also measured in grams, milligrams. So we have got all those prefixes in measurements. We need to understand them. Now I'm going to put 1 here as a reference point. On top, I'm going to be putting positive powers. Okay, so I'll be writing numbers. Basically, what you have written 1, what I've written is 10 to the power 0. So I'm going to have 10 to the power positive 1, 10 to the power positive 2, from positive 2, and then I'll start moving in multiples of 3. So I'm going to have 10 to the power positive 3, 10 to the power positive 6, and 10 to the power positive 9. And then down also I'll put the same, but we'll be moving in negative powers. But 10 to the power negative 1, 10 to the power negative 2, 10 to the power negative 3. From negative 3, we'll start moving in multiples of 3. We'll go from 10 to the power negative 3 to 6, 10 to the power negative 9. Okay, like this. Now remember, I've said 1 is a reference point. So when you are going up, something that is 10 to the power positive 1, the prefix that is going to come in front of a unit. For example, if the unit you are talking about is a meter, a prefix is something that comes in front. So something that you are going to put in front when you've got something that is 10 to the power positive 1 is deca. Deca. So you call it a decameter. Okay, decameter instead of just a meter. Decameter. So we're going to use capital D. For these units which are on top, we're going to be using capital letters. And then when you go to 10 to the power positive 2, positive 2, this we call it as hecto. Hecto, capital H. And then 10 to the power 3 is something that is very common, we know. This is a kilo. This is where a kilometer comes from. We use capital K. We have got 10 to the power 6. This is a million. We call it a mega. Capital M. We have got 10 to the power 9. That is a billion. We call it a giga. Capital G. We also have 10 to the power 12. Remember, it's multiples of 3. That is a trillion. We call it a tera. Now, I don't have where to write this. Tera. That's where terabyte comes from. Tera whatsoever. A trillion. And then as you get to go down, remember 1 is a reference point, so I'll not put anything here. This is reference point. So 10 to the power negative 1, we call it a deci. This is where we find deciliter, decimeter. Now this one we're going to be using small letters because they have negative powers. 10 to the power negative 2, we know this one. This is called a cent. This is where you come to find centimeter, because the centimeter is smaller than a meter itself. And then I've got 10 to the power negative 3. This is called a milli. Milli. Now this one, you don't follow the letter, the M in front. You use uh, anyway, this one you follow M actually. Now 10 to the power negative 6 is called a micro. Now since you have got two M's, you have got M here, you've got M here. Obviously you can't use both of them to represent those two units. So for micro, you use mu. It's more like a U but not a U. That's a symbol, a mu. And then you've got 10 to the power negative 9. This is called a nano. Nano. You use small n. I can also put, remember on top I put 10 to the power 12. I can also put 10 to the power negative 12. This is called a pico. This is where you get picometer, picowatt. So I want you guys to know these, like you need to know them. You need to know them by heart. No one is going to give you, and this is very simple to know. Yes, yes, please, Jesse.
So they just end up to two.
They go on. They'll be moving in multiples of three like that. Now, for you guys, this is where you need to concentrate. This is what you are going to be tested on mostly, and mostly they are going to concentrate on the negative because you are doing mostly chemistry, and chemistry deals with small things. Yes, now, yes, now you can go on. I can't get you. You can just say that again. Or positive 12, that is Terra. Terra. Okay. So let me remove this. Now, what I want you to take note is which one has a negative power, which one has a positive power. Friends, me, I studied this some time back, and I'm not using anything to bring them out to you. So I don't expect you to be moving with a book if someone asks you what is Terra, unless you move with a book for you to know. No, I don't expect you to do that. Now, knowing this should help you understand how to convert between units. Let's say you've been given 20 meters. They ask you to convert to centimeters. So what you are going to do is, you've seen this is just a meter, right? You don't have anything in front here. You don't have anything in front. That means there's no prefix. So this is the reference point. That is why I put that one is the reference point. There's no prefix in front. There's no kilo. There is no milli. There's no what. So to convert this to centimeters, we'll say 20 meters. I'll multiply. Okay. I have got a meter here. I'm going to put a meter down. The reason as to why I'm putting a meter down is because this one on top and this one down can cancel. Alright? They can cancel. And then I'm going to put a centimeter on top. Now, what I want you to realize is, remember a cent. A cent was one of those which carried negative powers. So this means that a cent in reference to a meter itself is small. Okay? A centimeter is smaller than a meter. So to a bigger unit, always know first which one is bigger. Between a centimeter and a meter, which one is bigger? A meter is bigger, so I'm going to put a 1 in front of a meter. Now, a cent, remember cent was 10 to the power negative 2. Now, even if it was 10 to the power negative 2, I will not put a negative 2, instead I'll put a positive 2. Why have I put a positive 2? Because I've put a 1 in front of a bigger unit. Please, as long as you know which unit is bigger, always write the power on top as positive. As long as I've put a 1 in front of a bigger unit. Please, that will not confuse you. It will never confuse you. So here the meter will cancel with the meter. So 20 times 10 to the power 2 is 100. This is going to give us 2000 centimeters. Meaning that 20 meters is the same as 2000 centimeters. Okay. Let's say we have got 40, let me say, milliliters. You want to convert just to liters. How can you convert that? So I'm going to write this 40 milliliters. I'll multiply. Since I'm seeing a milliliter on top, I'm going to put a milliliter down. And then I'm going to put a liter here. And which one is bigger? Remember, milli is one of those units which carry the negative power. mean that milliliter is smaller than a liter. So I know a liter is big, so I'm going to put a 1 in front of a liter. And then milli was what? 10 to the power negative 3. But since I've put a 1 in front of the bigger power, a bigger unit, I'm going to write 10 to the power positive 3. So milliliter will cancel with a milliliter. So this will just be 40 over 1000, which is going to be, physics you use a calculator. So you can divide, it's just maths where you don't use a calculator. So that is going to give you 0.04 liters. So I mean that 40 mils is the same as 0.04 liters. Let's say the question we are given was convert 5, let me say, grams, convert it to gigagrams. 5 grams convert to gigagrams. I know we are used to kilograms, not gigagrams, but we can convert. So what I'm going to do, I'm going to get a 5 grams. I'll multiply. Since I've got a gram down, I'm going to put, I've got a gram on top, I'll put a gram down, and then a gigagram on top. Now remember, giga is one of those units which carry a positive power. Okay? So meaning that a gigagram is bigger than the reference unit itself, a gram. Remember, a gram doesn't have any prefix in front. So I'm going to put a 1 in front of a giga. Remember, giga, what does giga mean? Giga means 10 to the power, that is a 6, right? No, 10 to the power 9, that's a billion. So I'm going to write 10 to the power 9 here. Always write positive as long as you've written a 1 in front of the bigger unit. So this is going to be equal to a gram. We'll cancel with a gram here. Now, since me saying 5 over 10 to the power 9 is going to give me 0.0000 a lot. So this is why standard notation is very important. So I'll just write this as 5 times this 10 to the power 9. I'll take it on top, so it becomes 10 to the power negative 9, and then we're going to have gigagrams. Meaning that 5 grams is the same as 5 times 10 to the power negative 9 gigagrams. This is how you get to do these conversions. Do we have any questions? Any question? Yes, Kristen.
So just repeat on the gigagrams. I didn't get it clearly.
Okay, so we are converting from gram to gigagram. So since we have got a gram on top here, we're going to put a gram down, and then we put a gigagram where we want to go on top. Okay, and remember, giga is one of those units with a positive power, right? Meaning that it is bigger than a gram itself. So I'll put a 1 in front of a gigagram because it is bigger than a gram. And remember, giga means 10 to the power 9. So down, I'll put 10 to the power 9. So I would have converted just doing that. And then what remains is just to do multiply. Is that okay?
Yes, that's fine.
Yes, Casey.
Yeah, can you repeat on the first one?
On the first one. Alright, instead of me repeating the first one, let me make it complex so that you understand. So let's say we've been asked to convert two uh, megagrams to micrograms. That's the question. Convert 2 megagrams to micrograms. Now you can see both contains a prefix. Now the best is you can't convert, like you can convert, but the best is you shouldn't convert direct because you don't know how many megagrams make up a microgram or something like that. So firstly, I need to remove the prefix so that I just remain with a gram. Okay, so I'm going to say 2 megagram. I'll multiply. I want to just go first to a gram. Okay, so since I've got a megagram here, I'm going to put a megagram down. I just want to go to a gram like that. Now remember, mega is one of those units with a positive power, so meaning that a megagram is bigger than a gram. I'll put a 1 in front. Now remember, mega is a million, means 10 to the power 6. That's when I'll put it on top. This means that this megagram will cancel with a megagram. Now our answer is in grams, but we don't want in grams, we want in micrograms. Now I can convert from the micrograms, I mean from the grams to the micrograms. We have got a gram on top, so I'm going to put a gram down. We want now to go to a microgram. Now remember, micro is one of those prefixes with a negative power, so I'm going to put a 1 here. Okay, because a gram is going to be bigger than a microgram. Why? Because a micro is one of those prefixes with a negative power. What does micro mean? Micro means 10 to the power negative 6. But because I put a 1 in front of the bigger unit, this will become 10 to the power positive 6. And then this gram will cancel with this gram. Here, we would have converted to micrograms. So this is going to be 2 multiplied by 10, 10 to the power 6 multiplied by 10 to the power 6, same bases multiplying at the powers. So this is going to be 10 to the power 12 micrograms. So this is a conversion. We have converted from megagrams to micrograms. Are we okay? Yes, Messi.
Yes, sir. Just on the 10 to the power 12.
Yes.
Is it does it remain 10 to the power 12 or it becomes 10 to the power negative 12?
No, it will not go to the power negative 12, because remember, unless if it was in the denominator. So we are multiplying things which are on top. So with a 2. So everything which we are multiplying is on top. So the powers are going to be positive. But if these two were down, when they multiply, by the time we take them on top, they would have had now negative powers.
Okay.
All right. Do we have any question? Abigail says she's okay. Do we have other questions? We're now going to practice questions from the exam and the tutorial sheet. Now, this topic is very, very important, especially for you guys who are doing medicine, pharmacy, for health related things. You are going to apply this knowledge when giving a dose to a patient. Those are the some of questions we're going to be looking at. Okay, so let's start. Before I go to the questions, do we have a question? Any question? Okay. So let's start with this one. Let's hope you are able to. This is from last year's exam. Delivering medications is another critical function that you perform many times on every shift, and mistakes in dosage can have very serious consequences. Dosage calculations ensure patients receive the correct amount of each medication. A medical doctor orders 300 milligrams of ibuprofen to be taken by a 6 kg infant every 4 hours. The label shows 75 to 150 milligrams per kg per day max. Is the physician's order within the normal range? Show you're working to support your answer. Now, you have got this medicine which is showing that you need to take 75 to 150 milligrams per kg. Like if you have got 1 kg, then you take 75 to 150 milligrams per kg per day. Now, this is a 6 kg baby, a child. The doctors order that every day this child should be taking every 4 hours this dosage, and he should be taking 300 mils or milligrams. Now, is the doctor's prescription within the normal range, or this prescription is going to hurt the patient? So how do you do it? So remember, the normal one we have been given as 75. The normal dosage is 75 to 150 milligrams per kg per day. So this is, so the dosage that you have been given, we also need to convert it to be in milligrams per kg per day, and then we are going to determine if the dosage is within the normal range or not, because that is how we've been given the prescription. So let's start. So the doctor orders. Now remember, we need to have been milligrams per kg. Okay, so I need first to get what have we the doctor given as a prescription. The doctor has given 300 milligrams, okay, to be taken by a 6 kg person every 4 hours. This is what the doctor has given. Now firstly, since we want to convert to milligrams per kg, what I'm going to do is to know this dosage. So what are we calculating? We are just calculating the dosage. Let me just say D. If I want, I shouldn't even put anything. So D is just meaning dosage. Okay, so the dosage that the doctor has prescribed is going to be, we have got 300 milligrams. Now remember, I want to convert them to milligrams per kg. This person is having how many kg? 6 kg. So I'll just divide this by the 6 kg. Why? I want the answer to be in milligrams per kg. Alright, so this is going to give us 6 into 300. Is that going to be a 50 milligrams per kg? Okay, so I've just divided the milligrams with the kg to have the answer in milligrams per kg. So we have seen milligrams per kg. Now remaining per day. Okay, per day. Now this doctor said the child should be getting this medicine every 4 hours. Okay, every 4 hours. Now what we are going to do is how many hours are in a day. Now by the way, the word pay means divide. Okay, it means divide. So basically I can also write this as 50 milligrams divided by kg. All right, and then I'll multiply. Since I want per day, okay, in other words, I need per. Remember, I've said it means divide. So I need the day to be in the denominator. But here we've been given in hours. So I'm going to say 1. I'll just put the hours down. Okay, we just divide by the hours. So then the answer is going to be in what? The answer is going to be, let's say, 50 divided by 4. The answer is going to be 12.5 milligrams per kg per day. Now this, I mean per hour. This hour, remember, is down to multiply with this hour. Okay, so that is going to be kg hour. Now remember, I don't want the unit to be in hours. So before I even get to finish writing that, I don't want the unit to be in hours. I want it to be in per day. So I'll multiply. We have got hours down. We are going to put hour on top. And we want to go to what? To days. Between an hour and a day, which one is bigger? We know a day is bigger. In one day, how many hours are there? We have got 24 hours. So these hours will cancel with the hours here. Okay, so the answer is going to be 4 into 24. That is it a 6? Right? And then we are going to now multiply this 6 by the 50. Let's see what we get. That is going to give us, is it 300? So this is going to give us 300 milligrams per, instead of me writing over, I'll say per kg. Now remember, this day is in the denominator. Instead of me writing over, I will say per day. So basically, what the doctor has prescribed is for this child to be taking 300 milligrams per kg per day. Now look at the normal range. It is 75 to 150 milligrams per kg per day. So you can conclude yourself. Is a doctor within the normal range? Who can conclude? Is a doctor within the normal range? Or you think this prescription is going to harm the child? Anyone?
Sure.
Patra, you can say that again?
I was saying that the prescription is going to harm the.
Yes. Okay, the prescription is going to harm the child. Why? Because it is outside the normal range. So this is why, as a specialty medical practitioner, you need to know units and measurements. Otherwise, you're going to give a wrong prescription to a person. They end up dying. All right. So you might not understand here. We have got another type of question as this one. We'll look at it. Okay, let's look at this one. Suppose hair grows at a rate of 0.79375 millimeters per day. Find the rate at which it grows in nanometers per second. Because the distance between atoms because the distance between atoms in a molecule is on the order of zero point 0.1 nanometers, your answer suggests how rapid atoms assemble. So this statement from because is just trying to give you more information about the answer that you are going to get, what it means. Right. So the question is, suppose air grows at a rate. So we've been given the rate. Okay, I'm going to give you the questions. Actually, there are other questions that I've kept for you to go through. All right, I'm going to send. So the rate we've been given as 0.79375 millimeters. Remember, it's given as per day, and I said per means divide. So per day. Now the question is saying convert that to nanometers per second. So the first thing I'm going to convert to nanometers. So what are we converting? The millimeters, we convert it to nanometers. How do you do that? We are going to multiply. Okay. So the answer for the previous question was the 300, and it was outside. The doctor was outside the range. So I'm going to multiply. Now remember, before we go to nanometers, we've been given millimeters. We first need to remove this prefix milli. So we need to convert first to meters. So I'm going to put the millimeters down, right? And then a meter on top. You know that a meter is bigger than a millimeter because a milli is one of those prefixes with a negative power. So I'm going to put a 1 in front. And then millimeter is 10 to the power 3. This means that a millimeter and the millimeter cancel. So the unit is now in meters per day. Now we don't want meters, we want nanometers. So again we convert. We'll put a meter down and then a nanometer on top. Remember, nano is one of those units with a negative power. So we are going to put a 1 in front of a meter because it's bigger. Now nano is 10 to the power negative 9, but to write positive 9 because we put a 1 in front of the bigger unit. So the meter will cancel the meter. So the answer is now in nanometer per day. Now we don't want nanometer per day, but per second. Mean that we have now to convert a day to seconds. Okay. So we are going to multiply. We have got a day in the denominator. I'm going to put a day on top. And then from there we're supposed to convert to hours, right? We know that in one day we have got 24 hours. So this day will cancel with this day. Now we can convert from hours to minutes and then to seconds. But actually I can just go direct. Okay? I can just go direct. So I'm going to say someone has a question. I've not understood the question which you've typed. Those with negative powers, what have you said? Please be free to. Yes.
Those that have negative powers, you don't put a one.
We put now, like those with negative powers are smaller units, so basically that's why you end up putting a one in front. We're always putting a one in front of the bigger unit. As long as it will be bigger than the other, you put a one there. Okay.
One.
All right. So here we have got a hour. Now for me, I can convert direct hour to seconds. So since I've got hour down, I'm going to put hour on top and then second here. We know that in 1 hour we have got 3600 seconds. So this hour will cancel with this hour. Why? Because in 1 hour we have got 60 times 60. 60 minutes and then 60 seconds in a minute. So that will be 3600 seconds. So All we do is multiply this, then you would have found your answer in nanometers per second. So what we have is, let me start, 0.79375. So here I can say 10 to the power 3 can go into 10 to the power 9, the answer will remain 10 to the power 6. Like same bases, dividing, subtract the power, so it will just be 3 minus 9 minus 3, that give you 6. So I'm saying 0.79375 multiplied by 10 to the power positive 6 multiplied by, on top we don't have anything else. Okay, so divided by, in the denominator I've got 24, then divided by 3600. So this is going to give us 9.18692 96 nanometers per second. So this is the answer. We can actually leave it as 9.2 nanometers per second. So this is how fast hair grows in nanometers per second. Do you have any questions? All right. Then
So you've used the calculator?
yes, I've used the calculator. The traffic
Leave it
lights,
like that.
pardon?
I was saying you can't leave it like that, like over 24 shine 24.
No, no,
Like it should have been done.
you need to find the exact answer. The traffic light turns green and the driver of a high performance car slams the accelerator to the floor. The accelerometer registers 22 meters per second squared. Convert this value to kilometers per minute squared. Okay, this one actually even came in our test one. Alright, so we want to convert meter per second squared to kilometer per minute squared. So I can as well write this as 22 meter per second squared. I write a denominator. It is much easier to work like that. And then I'll multiply. So we have got a meter here. So we're going to put a meter down. Remember, I want to go to a kilometer. So I'm going to put kilometer on top. You know that a kilometer is bigger than a meter, so I'll put 1. And then kilo means 10 to the power 3, so it will become positive. So the meter cancel with the meter, right? And then again I'll multiply. We have got a second down, so I'm going to put a second on top. And then we want to go to minutes, right? I'll put a minute down. Now we know that a minute is bigger. In 1 minute we have got 60 seconds. But remember, this is second squared and we want to go to minute squared. But this is just second, this is just a minute. So what you do, put everything in brackets, you square on top, and also put everything in brackets, you also square. So if it was cubed, you put everything in brackets, you cube. Please, not just the unit, also the number. Alright, so this is going to give us, if I square 60, that is going to be 3600, is it? 60 times 60, 3600. And then if I square a second, it will be second squared. So that second squared now cancels with the second squared down here. So the answer then, we are going to get the 22, which is here. We are going to multiply that with 60 squared. So in the denominator, we are now going to divide. In the denominator, we only have 1000 there, right? Which is 10 to the power 3. So the answer is going to give us 79.2. What unit do we have on top? We only have a kilometer. And then per down, what unit do we have? 1 squared is just a 1 minute squared to be a minute squared. So this is going to be the answer, 79.2 kilometer per minute squared. That is the same as 22 meter per second squared. Are we okay? Are we good? All right. If the density of carbon tetrachloride is 0. If the density of carbon, yes, Messi.
Sorry, I didn't get the last part. You're too fast. the previous question.
So, can you get it on this question?
Um, okay, just the answer. It's just the answer.
Okay,
It was 9 point what?
79.2.
Uh,
Mr. Hero, do you have got a question?
All right. It is just on the answer there. No, but I'm clear because I thought uh, it was bigger than the one which was in meters per second described, whereas meters are smaller than kilometer.
Oh, I see.
Yeah.
I see. Actually, it's supposed to be that, just like density. Density of water is 1 gram. Is this 1 gram per centimeters cubed? But in kgs, it is 1000 kg per meters cubed. This has to do with the conversions. So you see, the kgs and the meters cubed are bigger, but they've got 1000. The gram and centimeters cubed are smaller, but it's 1. Yeah. So here we've been given the density of carbon tetrachloride as 0.793 grams per milliliter. Now I want to convert a, a sample has got a volume of 9.29. What is the mass? I know we know the formula for density. Density is mass over volume. Now, since we are talking about units and measurements, I'll not use the formula. All right. So I've got 0.793 grams per milliliters. And then we've been asked to find the mass. So notice that mass is given in grams, right? So the question is, how can I cancel out the milliliters? So just multiply. Okay, you've been given something in milliliters. So multiply by 9.29 milliliters. So the milliliters will cancel the milliliters. The answer will just remain in grams. Then you would have converted. Or you know that mass is given by density multiplied by volume. So that's, you see that dimensions also confirm, they confirm formulas. That's the application of dimension analysis, to confirm the validity of a formula. So 0.793 multiplied by 9.29, that is going to give us 7.36697 grams. So that's the answer. If they wanted in kilograms, you can convert. Okay. The next one. The human brain is located in the upper portion of the head with a volume that could be approximated by a cube. Okay, by a cube. And a cube is about 20 centimeters on a side. Like something like this. You know, a cube has got all the sides the same. So meaning that each side is 20 centimeters. That's approximately the length of each side of the brain, right? 20 centimeters. Now, brain cells consisting of 10% neurons and 90% glia vary in size with dimensions ranging from a few microns to a meter or so. Taking d as 10 microns as a typical dimension and consider a cell to be a cube with each side having that length. In other words, the brain itself is a cube, right? It is 20 centimeters on each side. But it is made up of cells, okay? And each cell, the distance of each cell, the typical dimension of a cell, so more like this. You have got the brain. Okay, each side is 20 centimeters, but the brain is made up of cells, and each cell, each side is 10 microns. 10 microns. Now the question is, estimate the number of brain cells in the human brain. So how many cells do you have in a brain? So that is basically the question that we have. Now the question is, how do you find the number of brain cells? So the first thing, we need to find the volume of the brain, like the space that the brain occupies. And then we need to know the volume occupied by each cell. And then we just say how many times can the cells go into the volume of the brain? Then we would have found the number of cells. You see, like you don't need a formula, it's just an application of dimension analysis. So let's find the volume of the brain. So since it is a cube, you know that volume of a cube is given by length to the power 3, right? Length times length times length. Yes, Martha.
So sorry, I didn't get the whole explanation about this question. Like it's
Okay.
like you're speaking some things I can't understand, like consisting of things and
No,
I don't even
don't worry about this. Like this is just what a cell is made up of. They say brain cells. Now brain cells are made up of these neurons and the glia. Now this will not determine. You have got a brain. The brain is made up of brain cells. So we just want to find the number of brain cells. We know brain cells consist of neurons and the glia. Now that's not your point of interest. Like you just want a brain cells. That's why I've not concentrated on that. Okay. Here there's a hand.
haven't understood the question.
Okay, so the question is basically telling us we have got a brain, right? Your brain is a cube, more a cube, and each side is 20 centimeters. And then the brain, you know that the body is made up of cells, right? So the cells in the brain, they are also in form of a cube, and the cube has got each side has 20 microns. Okay, the micron is more like a micrometer, like that. Now I want to find how many cells are in the brain. That's what we want to work out. So the first thing we need to do is we need to find the volume of the brain. We find the volume of a cell and then we divide that to give us the volume of each cell. I mean how many cells are in the brain. Is that okay? Mtinta.
Yes, okay.
Alright. So we've been told that the brain has got what? Yeah, is 20 centimeters, right? 20 centimeters. Okay, so I need to convert the centimeters to meters and then cube it for me to find volume. So what I'll do this. We have got 20 centimeters. I'll multiply. We have got a centimeter on top. I'll put a centimeter down and then a meter here. In 1 meter, we know I've got 100 centimeters, right? I'll put the 100 down or the 10 to the power 2 down because the centimeter is smaller. So this will cancel with this. So the answer is now in meters. Now this which we find, we raise it to the power 3. Okay, because we're finding volume. So that is going to give us about 8 times 10 to the power negative 3 meters cubed. Okay, that is going to be the volume of the brain. And then we find also now the volume of each cell. Since also cells are in form of a cube, so volume will be L cubed. Yes, Casey?
So why is it 8 times, what's this? 10 to the power negative 3.
Punch on the calculator. 20 divided by 100 raised to the power 3. Punch that on the calculator if you have. So now we have got the microns here. Casey, you have a question? Okay, so let's convert also the microns to meters. So I was saying basically a micron is a micro, okay, micrometer. So we'll say 10 times, oh, this is given as 10 microns. Let me write a symbol micrometer. Or multiply, we have got a micrometer on top, we'll put a micrometer down, and then a meter on top. So this is going to be, a meter is bigger, so we'll say 1. A micrometer is smaller, so that will be 10. Remember, micro is 10 to the power 6. And this is raised to the power 3. So punch this on the calculator. That is going to give you 1.0 times 10 to the power negative 15 meters cubed. Now, to find the number of cells in the brain, the number of cells in the brain. So we'll say number of cells is just like if you want to find how many let me see how many cups can go in a jug. You are going to be adding, right? You are going to be adding those cups of water in a jug. Or you say the volume of the jug, if the jug is able to hold, let's say, 20 liters, and then a cup is able to hold, let's say, 0.5 liters. So to find how many cups you are going to put in the jug to be filled, just say 20 over 0.5. That will give you the number of cups. So this is going to be 8 multiplied by 10 to the power negative 3 meters cubed divided by 1.0 times 10 to the power negative 15 meters cubed. So meters cubed and meters cubed will cancel because this is number of cells. It's a count. Like when you are counting, you don't have a unit. This will give you 8 times 10 to the power negative to the power positive 12. So this is how many cells there are in the brain. Now we want to leave the answer just as order of magnitude. What is order of magnitude? If I've got a number like from 0.5 up to 5, okay, any number like this, I write maybe, let's say, 2 times 10 to the power 3. This power you're able to see is what we call order of magnitude. Like this number is in thousands. That's the order of magnitude. Now if I exceed 5, like 6 times 10 to the power 7, the order of magnitude of this one is going to be 7 plus 1. That is going to be 8. Like this number is more, just the way we round off, okay? Like the way we round off. If a number is above 5, you remove a 1. So it's more like you remove a 1, you put there, it becomes 8. So the order of magnitude of this one is 8, order 8, right? So this one, since this number is above, so I can also round off this number as 1 times 10 to the power positive 13. So this is the order of magnitude. It has order 13. So this is like you can't determine the exact number of cells. This is an approximation. That's why you'd rather give it as an order of magnitude. Okay, so the order will tell you that the cells are in a range of about uh, 10 trillion cells in the brain. That's the meaning of this answer. 10 trillion cells in the brain. Yes, now, pardon? I can't get you. Yes, Musonda Mlonga.
On that one, for the powers, y is 10 to the power negative 3 and y is 10 to the power negative 15. How come it's 10 to the power 12 there?
10 to the power negative 15. Oh, no, like, okay. You've seen this is 10 to the power negative 3, right? This is 10 to the power negative 15. You know that when you are dividing bases of the numbers of the same base, just subtract the powers, right? So it will be negative 3 minus negative 15. Msonda, what are you going to get?
Okay, then it would be negative 3 plus 15,
What does it give you?
12.
Yes. Okay, let's look at. Yes, Casey.
So I didn't understand the last part where you found 1 times 10 to the power, is it 13?
So what I'm saying is you write it as an order of like you just show the order of magnitude in what ranges of numbers. Like if we write like this, it means we've given the exact value. But obviously you don't you not say that the cell or the brain has actually an exact value of 8 trillion cells. So that's why we are saying it is in an order of 10 billion cells, in that range, in a billion number of cells. I mean trillion number of cells. So you round off, if you round off 1, I mean 8, it is much closer to 10, right? But I'll write 1, isn't it? And then if I write 1, or in other words, I wrote 10. If I round off 8, it is closer to 10. Now 10 times 10 to the power 12, that will give you 10 to the power 13. That's the thing. So if we add 2 times 10 to the power 4, this one rounded off is just 1 times 10 to the power 4 as an order of magnitude. Is that okay?
Yes.
A label of a certain medication is showing 60 to 200 milligrams per kg per day max. A medical doctor, an MD, prescribes 400 milligrams of paracetamol to be taken by an 8 kg infant every 4 hours. Is the doctor's prescription within the normal range? So the normal range is 60 to 200 milligrams per kg per day. Maximum, like you can't exceed this. Now the doctor has prescribed what we are able to see. Now is that within the normal range? So first I'm going to get the prescription that is 400 milligrams. Now I want per kg, right? I'm going to divide this value by the mass of the person who is going to take that. That is 8 kg. So then our answer is going to be in milligrams per kg, which is this first part. But we also need to have per day. So to find the per day, I'll multiply. Okay, I'll put one here. We want to have a denominator as a day. Now this person is taking for every 4 hours. Okay, for every 4 hours. Now again, this is going to be milligrams per kg per hour, but we want per day. So I'll convert the hours to days. So we know that in 1 hour we have got 3000. Oh, sorry. Let me first say hour on top because we have got hour down, and then a day here. We know that in 1 hour we have got not in 1 hour, but in one day we have got how many hours? 24 hours. So the hours can cancel with the hours. 4 can go there. That is what? A 6. So what we are going to do is 400 divided by 8 and then multiplied by 6. 400 divided by 8 multiplied by 6. This has given me 300 milligrams per kg per day. So you can conclude, was the doctor's prescription within the normal range or not? Anyone? Yes. Yes, Mutinta.
It was not within the normal range.
It wasn't within the normal range, so that is it.